Hello students, we're going to start now on assignment 3.2.3, which is using standard scores or z-scores to interpret scores on different scales. And you should have already read that chapter in your textbook. The whole idea of a z-score is to create a similar scale that allows you to compare two very different dimensions of an object, like let's say height and weight. You could have a person who was overweight and very short, or overweight and very tall, and then you could have the same thing with a tall person, but what you want to do is to be able to make some comparison on a similar scale. And the way standard scores work is you have everything centered to zero. So the mean becomes zero and the standard deviation becomes 1. So in that way, any score above zero, any positive score is above the mean, any negative score is below the mean. So we are going to use JASP to do two problems. One is where you enter data yourself, and the other is where we look at a career inventory. And you'll find that on the second sheet, and you'll see a number of names, and people will have a score on computer science, on business, on social work, and on teaching. And the question is, how do those scores match up as we compare them to the overall mean? And so that raw scores don't tell you very much here, but when we standardize these, we will get a score that does give us some more to work. Okay, so I entered the data. Actually, I sorted it from low to high first. One of the things that you probably remember from your textbook is that when you find the median or the 50th percentile, the formula for that requires you to sort from high to low first, and then you find the location of the middle score. That is the way these work. So in this case, I want to show you how to use the Jamovi program to calculate the z-scores. And there's a formula on your homework worksheet if you wanted to do this by hand or in Excel. What you do is first find the mean. The mean is provided for you here, 86.8, and the standard deviation, and you subtract the mean from each one of these values and divide by the standard deviation, and that will give you a standard score. But we can also do that in Jamovi. It allows you to transform the variable. So let's go ahead and do that. I'm going to go to Data, select Transform. Under the Transform, the type of transform, create a new transform. I will go here to the functions, select functions, scroll down to the Z, double click the Z, and then I have to put the source variable, which is the variable that we have highlighted, in parentheses, and hit enter. And from there, we will end up with a new variable, A transformed as a z-score. And one of the things you should see right away is that we start with very negative values, 1.7, and we move to something very close to 0. That would be our negative, our 0.17, which is very close to our mean of 86.8. And then as we move toward higher values, the z-scores get larger. And what we know is that about 86%, or 68% of the cases fall within one standard deviation above and below the mean. So at this stage, I want to analyze these. Let's take both variables and take a look at them in the analysis. We're going to go to exploration, descriptives, and identify our two variables. I'm surprised that it did that for me without me converting that to a metric first, but it did. So anyway, when we go back, I'll do that. What you see here is, let me choose the ones that I want. I want the median. Look at the mode. We get the percentile, the 25th, the 50th, and the 75th. And the 50th, remember, is always the median. We get the standard deviation interquartile range, which will be the 75th minus the 25th, that gap in there. And then for our plots, we will take a look at the box plot and the histogram. Okay, let's take a look at what we have. So here you see that the mean for our transformed variable is a 0, is 16, it's 4.63 with 16 zeros in front of it, which is 0. And we also have a standard deviation for our transformed variable of 1. And so that means that now we are looking at a mean of 0 and a standard deviation of 1, where we have taken this variable and transformed it into a standard variable, and another name for that is z-score. And then this is our distribution. It is not exactly normal. Now, in order to use the z-table, in order to come up with accurate measures of percentile rank, you really need an approximately normal distribution. But this one is not this one is sort of symmetric, but because of the gaps, I wouldn't trust it with accurate scores. But here are our here's our interquartile range right here, between I think about 84 and 92. Let's see what it is. It is between 84.3 and 90.8, 91. And this is, so you see that the look of the two, the shape of the distributions is the same. Let me move this so you can see it. For the raw, it's almost exactly the same. It's a little different, but it should not have changed the shape. But now you see here the midpoint is 0, while the midpoint over here is the 86. So that is the way you will use Jamovi to do this, and from there you can answer the questions. And let me remind you that when you answer the questions, some of those are going to require you to use your textbook, the Erden textbook in particular. Go to the chapter on standard variables, and you'll see the normal curve and what percentage of the cases fall within 1 standard deviation above and below, and 2 standard deviations and 3 standard deviations. And then from there we will start looking at, in other assignments, how to use the z-table to estimate the percentage of scores that are equal to or less than, which is the definition of a percentile rank.